For question 6, what I wanted to show you is that when we have some genomic sequence, we could look for an mRNA sequence that matches that, or we could look for a protein sequence that will match my genomic sequence. And you're like, Dr. T, are you crazy? The protein doesn't match DNA. And I'll go like, okay, but remember, BLAST can do this job. It can make the 6-frame translation of this. So what it does is that it says if these were proteins, which proteins could it be? So it makes 6 of them, and then it does a search between each of those 6 theoretical proteins in the protein database. But this search takes so much longer than the nucleotide searches we're doing. So when I did 97,000 base pairs, it only took, I don't know, a minute. And I was trying to do that with BLASTX, which is the thing that takes this sequence, the whole thing, and translates 6 frames, and then compares to protein database. And it took forever and then timed out. So after a bunch of trials, I found that, okay, with 27,000 base pairs, which is what this sequence down here is, no, all this, it is possible to do it. But I also wanted you to get the feel of it takes longer because it's doing that much more work. It's doing 6 searches instead of 1 after it does the reverse or the translation in 6 frames of this. So if you copy this whole sequence of the whole block here, the 27,000 base pairs, and you throw it in BLASTX, so BLASTX, it doesn't tell you here, but BLASTX is the one that takes your nucleotide sequence and it translates in 6 frames and looks at the protein database to see any of your 6 frames, does it match protein database. So a lot of uncharacterized, that's common to see, the predicted or uncharacterized. Those are not really exciting. I like to know, okay, the ones that we know something about, this is some name of a clone, but just because it doesn't say uncharacterized, I'm like, let's see where it matches. So let's see, hypothetical, I wanted to see some function. Predicted, this one, retro element. So that's actually the reason why I picked this part of this sequence. I wanted to show you that sometimes you get these guys. Do you remember Barbara McClintock? Well, her. So let's see. Here you go, another one. So transposase. Remember the jumping genes? Yeah, that's what these guys refer to. Let's see what else. Maybe I missed. Predicted. Retro element. Uncharacterized. Mutator-like. Transposase. All right, so let's see where they match my genomic sequence. And the cool thing, or the weird thing, I don't know, cool, weird, whatever you call it, is that, so there's this match here, right, which this part matches, that part matches my genomic sequence. This thin line here is the part where they don't match. But, so that is, okay, that's chunk of Arabidopsis, which is that too. But, so that part doesn't match anything in here, but then there's this piece of DNA that matches that middle. So what do you know? That is the mutator-like transposase. So it looks like this transposase is transposed, so it inserted itself within this other gene. So that happens sometimes. And I thought this would be interesting for me to show you that.